we've got a couple more minutes before we start, but let me point out that all of these slides are available at this website. So if you go to, this is my website, and if you click on Quick Links, you will see at the very top a link to all of these slides. So you don't need, and you can look at them with your phone too. And so you don't need to, well, you can look through the slides and see if this is an interesting talk or there's two other talks going on. And if this doesn't interest you and you want to go to the other talks, it will not offend me. As you will find tonight when we do the open spaces, part of open spaces technology is the law of 2 feet. And when I go to conferences, I use the law of 2 feet myself. If a talk isn't keeping me interested, I go to another talk. So feel free to do that. It won't bother me. And if you want to know more about me, if you go to the same website, you can find my bio and bibliography and other interests, other things about me, including links to books that you can download, like both Thinking in C++ and Thinking in Java are available to download if you want. Also, this presentation is going to be videoed, so it'll be on YouTube at some point, so you can watch it there too. If you, you've probably learned about this already, we'll be taking questions through this system, which I haven't used before, and my understanding is that somebody is maintaining this so that they're figuring out what questions are moving to the top of the popularity list. And so go ahead, if you have questions, post them there, and we'll figure out how that works. During the rest of the conference, well, tomorrow, basically, one of the things that I will try to do is post something that if there's a topic that people want to discuss or if you have questions you want to ask, I'll let people know where I am. If we get a larger group, I might see if there's one of these rooms available and we can do it there. Otherwise, it'll be out in one of the lobby areas, and we'll try and do our own kind of open spaces. If you want to know more about open spaces, this link from the Winter Tech Forum, which is a conference, a much smaller conference than this, that I run in my town of Crested Butte, Colorado. And there's a full description of how open spaces work, which is what we're going to be trying to do tonight. And more or less tomorrow, well, we'll just wing it there. Probably we'll put the any information about where I'll be for these discussions on the GeeCON Slack channel. If you're not part of that, you can join. You can also try putting, if you're interested in discussing a particular topic, you can put it on Slido or onto the Slack channel. So here are some of the new projects that I'm working on. I've started a co-working space in my town of Crested Butte, Colorado, and you can click on that link to learn more about that. That's a work in progress. And I've also been studying, for maybe the last 10 years, I've been studying alternative organizational structures and trying to, well, lately I've been trying to develop a flat organization. I had a couple of people who were graduating from college come to me and say that they would like to work with me, and I said, okay, we'll see what we can do. And so we're trying to create a software development organization. And if you go to this link, there's nothing there yet. This is still fairly new, so we're just putting up the website. But the goal here is that it be a flat, self-managed organization, and what I would like to do is see what happens if we optimize the developer experience. So the two people who are working with me now, they work as much or as little as they want to, and I'd also like to figure out how to allow them to work on the projects that they're most attracted to, because I feel like that's something that will make their experience better, and as a result produce better code, or at least that's what I'd like to see. Does this produce better code if we have happy developers? Seems like that's the case. The other thing that I have been studying, and I'll be giving a workshop on, well, back in my hometown, is something called nonviolent communication. Sometimes it's called compassionate communication or effective communication. This is because flat organizations don't have bosses to work things out if people have disagreements. So people have to do it themselves, and that's why I began studying this. But it turns out to be quite a useful thing. And there's lots of videos that you can find on YouTube, and there are many books on this topic. So, all right, so the basic subjects I want to talk about today are languages that I've been studying, and first, Kotlin, which I think will, as some of you may have seen, is already starting to disrupt Java. And also some things that you may or may not have heard of, which is the Julia language, which I believe will disrupt high-speed computing, and WebAssembly, which will disrupt front-end programming. So I'll go through these in order. And the first one is Kotlin, and I've been working for a couple of years now on this book, Atomic Kotlin. And the reason we call it Atomic is because we try and make these chapters as small as possible so that there's a single concept in each one, and each one is only a few pages long, so that you get that sense of satisfaction that you get when you reach the end of a chapter. You get that many times. And it takes a lot of work to do that and to understand the language deeply. And my co-author, Svetlana, was originally part of the Kotlin design team. So she was one of the designers of Kotlin, and she has a deep understanding. And so we've been working together. And you can get an early access ebook at this website, atomickotlin.com. So that's been most of my life for a while. And I've gotten the question a few times, well, are you going to update your Java work? I have been, I created a book called On Java 8, and it was an experiment to see if an ebook only format would work. And I also published it through Google Play Books, which seemed like a good idea at the time, but has turned out to not be the greatest approach. So, and that was for Java 8, and now Java's been galloping forward. So once I finish this book, I'll return to that, and I changed the name for it. I think it's called, the next version of that book is going to be called, I can't remember what I renamed the book, but it'll be on the website, or it'll come back to me during this talk. And so that will be, I would say, my final work on Java, since I own that instead of the publisher. So I'll be the publisher of that, and that will be in print form as well as ebook form. And then I'll maintain that periodically as the language changes. All right, so I got this shirt from JCommerce, and I hope they don't mind. It says, "I'll stop coding in Java when they make a better technology." Well, I think that's what Kotlin is. And what I'm going to look at with these three technologies is I've always kind of tried to figure out what is the philosophy of a language or a technology, and it's so that I can understand why they made design decisions. I was on the C++ standards committee for its first 8 years and began to understand how language philosophy would affect the design decisions that were made. And in C++, for example, one of the strongest issues was backwards compatibility with C. You had to be able to take C code and recompile it in C++. And people who aren't familiar with that look at C++ and feel like, well, there was a lot of goofy things that were done with the language. But if you understand that those things were done in the name of backwards compatibility, it makes more sense. It doesn't necessarily make the language easier, but it does allow you to understand why those decisions were made. And with Kotlin, I would say that the number one issue is that they want to be able to have Java interoperability to be very easy and seamless. In Scala, which I wrote a book called Atomic Scala before this, they wanted to have Java interoperability, but it wasn't particularly easy. So Kotlin is seamless. And that affects some of the design decisions, as we'll see. The other, I'd say, key principle in the design of Kotlin is to not invent features from scratch, but instead look at other programming languages and see what worked best in those languages. So the features that they added were tried and shown to be valuable. And that I really appreciate as a design principle, because I think it's made the language what it is, which I'm very impressed with the language. And I've almost never felt unhappy about the decisions that they've made, whereas with Java, there were a lot of decisions that were made which I felt were not particularly well thought out and have caused programmers grief because of those decisions, whereas Kotlin, I feel like they really worked hard to fix things that weren't working in Java and to incorporate new features, well, not new features, features that were proven. They also wanted to make a language that could support functional programming as much as possible and minimize the syntactic noise so that you have less code and that code is cleaner, and to solve problems that Java didn't solve. For example, we'll look at the null handling. So I'll look at 3 different pieces of the Kotlin language. There's lots of things, as you will see in the book, but I'll look at 3 small things. The first, well, if we go back to C++ and we look at, because it had to be backwards compatible with C, and C allows you to allocate storage on the stack or on the heap, C++ needed to differentiate between those 2 things, and it wanted to bring heap allocation into the core of the language rather than using malloc and free, which are library functions. So if we create a class that allocates some storage, one of the things we can do is we can allocate, this FS is being allocated on the stack. And so it's automatically freed whenever you leave the scope of allocation. And it's, so the stack pointer's moved up, you don't have to think about it. Whereas if you allocate it on the heap, for one thing, you have to use a pointer, and the other thing is you have to call delete so that it releases it, and then it's up to you. And so, of course, memory leaks are possible, et cetera, et cetera. Some of the newer versions of C++ have better ways to handle this, but ultimately, still, you have to pay a lot of attention to that. Whereas with Java, everything, in effect, is allocated on the heap, and you've got garbage collectors. So instead of using pointers, we use references. That's less noise. We allocate things on the heap, and then the garbage collector comes along and cleans them up when you're done with them. So a mystery here is, why did they still use new if it didn't need to differentiate between the two? And I don't know the answer to that. All I know is that, well, the answer they give to a lot of things is, we were in a hurry. Unfortunately, that stayed with the language, and it's a burden for all programmers to have to. Maybe it's a small one, but it is. It's a little example. Maybe they were saying, well, we're trying to get people to move from C++ to Java, so we'll leave the new keyword in there so it's familiar. I don't know. Anyway, if we look at the Python language, it doesn't have this extra visual noise. I can create a class called foo. Here, I say pass to indicate that this is just a placeholder. I can still use it. It doesn't have any definition at this point. I can define it later if I want. Now, when I create one of these, I simply call the constructor without the need for new. So Python has a garbage collector as well. It'll clean it up when it needs to. But I don't have to say new. There's no reason for it. Just as an aside, this is a type annotation in Python. The Python allows you to put these in, and there are programs that will check this, but it's not checked by the Python compiler at compile time, but it's an improvement. Anyway, that's just an aside. It's not particularly important here. Kotlin follows this minimalist approach. In fact, you could argue it's even more minimalist, because when I create class foo here, I don't have to say anything, and it understands that, okay, that's it. It's just a name that we're using. But then I can also give it a body if I want with other things. But for simplicity, I'll just say class foo here. And I didn't forget to add the semicolons, because Kotlin knows how to find the end of an expression without needing a semicolon. And this is one of the things that I appreciate with more modern languages, is that the compiler writers are willing to do the work to simplify my life by not having to put in semicolons. Now, when I define one of these things, I don't need the new keyword. They don't have a new keyword. So it looks like Python in that way. And the other thing that's happening here is I'm using a val. Kotlin has both vals and vars, and a var is something that can be modified, and a val is invariant. And it's also doing type inference on this. It's pretty easy in this case. It knows that this is a foo, and so from now on, the type of f is going to be this type foo. So the type inference is a very nice feature. You can also specify the type in effectively the same way that you're doing it here in Python. You use a colon and then give it the type. But you don't have to if it doesn't help. Typically that's with a local. If you're using like a local variable in a small scope and you feel like it's obvious what it is and you don't need to annotate it, you don't have to. All right, so a second example of a Kotlin feature is extension functions, which come from C#. And the first time I saw these, I thought that they were kind of trivial syntax sugar, because it's really just a function that doesn't have anything to do with the type that it's working on. So you could simply pass an object of that type into this function. But as you see them used, you realize, oh, this is really actually very nice. When you create one of these things, you can't violate the private or protected barriers. So it really is just like an ordinary function. What you're doing is you're adding syntactic functionality to these existing types. So I can even take something built in like the string class and add a single quote or a double quote extension function to it. And in Kotlin, we use the fun to define a function. And here, this is a single line function. So all I have to do is give the return expression. And in this case, I'm taking, well, there's a special keyword when you're defining a function. You can say this. And what this refers to is the string of interest. And the $, since it's inside of quotes, the $, takes that and turns it into, or produces a string. So here I'm adding a single quote, and here I'm adding double quotes. And when I call it, notice that I have this fun main, and when I call this function, fun main is just like your main function in C++, or your public static void main string args in Java, but you don't have to say all those things. So I like that because it's simpler and more direct. So I can take a string and I can call single quote and double quote for it. Now again, this just looks like syntactic sugar, but one of the things where it's really helpful is when you're interfacing between Java and Kotlin. And what they've done is they've taken classes in Java which are fairly limited, like, for example, the collections class. You've got, say, a list. And they can add lots of these extensions, but they don't have to do inheritance for it. They simply add these extension functions, and they don't modify that class. And so they can add, for example, functional behavior to a list, which is important. But you're still working with the optimized list class from Java. And if you want to take that and pass it back to a Java function, you can without doing anything to it. You just pass it in. So you can modify it inside of Kotlin and do all sorts of interesting things to it, and then pass it back to Java. And this turns out to be very powerful. So a lot of times, say, if you were doing this in Java, you inherit to add a bunch of methods to it, which is kind of a specious use of inheritance. Normally, you want to use inheritance for polymorphism, but when you see it used this way, you think that's one of the uses for inheritance, and I'm almost certainly guilty of teaching it that way. Whereas with Kotlin, if you want to use inheritance and polymorphism, you have to be very explicit about it. You have to say, you have to make the class open, and you have to use the override keyword to say that you're using inheritance. So it really directs you towards using inheritance for polymorphism and not for class extension, which you can do normally with extension functions. So the third thing I will discuss with Kotlin, one of the solutions that it solves, is null handling. And this is another place where when they were designing Java, they could have said, we're not going to allow nulls, but for some reason, again, they were probably in a hurry and it seemed like it was too hard. I don't know. Unfortunately, they didn't do it, and this produced much programmer heartache. With Kotlin, if you are writing pure Kotlin, it simply doesn't allow nulls. It prevents you from using nulls. And if Kotlin didn't have to interact with Java, we would be done with nulls. But again, one of the really important issues with Kotlin is that it seamlessly interacts with Java. So when you call Kotlin code, you must handle the potential, when you call Java code, you must handle the potential nulls that come back from that Java code. So Kotlin has to assume that those things will be nulls. And so it has a number of functions and operators to handle that situation. And again, if you're just working with pure Kotlin, you don't have to think about that. One of these is called the Elvis operator, and the reason that it's called the Elvis operator is if you kind of tilt your head over, you can see the two eyes, and you can kind of see his pompadour, his hair. Elvis Presley, maybe you're too young. I don't know. Anyway. So in the book, we created a tiny little test framework called Atomic Test. And the EQ function, what it does is it verifies that the expression on the left is equivalent to the expression on the right. It prints out the result, and if it's not correct, it will throw an exception. And that way we can ensure, not only can we show you what it should be, but in the test framework, we can ensure that the book is correct. It's giving the right answers. So here is an example of S1 is, and here I'm explicit about the type information. I'm saying that it is a string, and the question mark indicates that it may be null. And in this case, I'm assigning it to something that's not null. So and it's a val so that it can't be changed to anything else. So basically, here, the question mark is, in effect, redundant, but I put it in there because since this is what's called a nullable type, when I use S1, I have to handle that. And again, normally, you're not going to write code like this. You're only going to use a nullable type when you're interacting with Java that can produce nulls. But when I use S1, I have to, the compiler forces me to check to see whether it's null. And there's a number of different ways to do that. But the Elvis operator is nice because it says, check to see if S1 is null, and if it is null, produce this expression on the right of the Elvis operator. If it's not null, just produce S1. So in this case, it's not null, so it produces S1, and that is ABC. In the second case, S2, also the compiler forces me to, in this case, it forces me to put the question mark there because I'm going to assign it to a null. This is just an example. Again, you wouldn't do this in your Kotlin code except in very special cases. Normally, this is only going to happen when you interact with Java. So with S2, it could be null, and so again, I have to check it, but in this case, it actually is null, so it produces these 3 dashes. And that's what my EQ validates. So there's a number of things like this that basically don't allow you to ignore the fact that Java can produce nulls. And there are people who are changing to Kotlin for that particular reason. They say, I just want the null handling, and then they begin to learn the other things and get value from those. All right, so the second topic that I want to talk about is language performance. And for many years, I've tried to figure out, because I've been using Python since the late 90s, and I've been trying to figure out how can I contribute to the Python community? What kind of book could I write? And my friend Luciano Ramallo wrote a book that came out in the past few years that I would say I'm not going to be, if I wrote a book that was equivalent to Thinking in Java for Python, I would not be able to do better than this book. So this is your Thinking in Python. If you ever want to I mean, since you're all programmers, this would probably be the book for you. And if you want to learn Python, this is the book to do. And he's working on a second edition. I'm not sure how long that's going to take, but he's been working on that, started to work on that. And the first one is excellent. So I thought, well, that's not going to work. And then I was talking to Guido van Rossum and some of his folks, and the idea of doing a concurrent Python came up, and I thought, oh, that would be a more advanced thing and a good contribution that I could make. And I started working on that, and you can find that in my GitHub repo, but don't, because well, I'll tell you what happened. I started looking at it and kind of learning and understanding what concurrency in Python was about, or really about any language. It's about making things run faster, using your processors more effectively so that your programs can run faster. And there's lots of different strategies, and that's what makes concurrency confusing, is you have to kind of understand all these different strategies and decide and try things out. And your first guess, no matter how expert you are, may not be the right one, and you'll have to try multiple ones. It takes a long time to make something run fast. So then I encountered this language, Julia. And this was developed by some folks at MIT, some very smart people who stepped back and looked at the problem of programming for scientific programming and machine learning and just general problems. And they said, you know, there are so many programmers out here who aren't experts in many of these issues. And so what we would like to do is make a language for them so that they can create programs that run quickly, but they don't have to become experts. And they referred to this as the two-language problem. So often people would start in a language like R or MATLAB or Python or similar languages, Ruby perhaps. And it was very easy to write their program, but then they're dealing with massive amounts of data and they have to optimize it. And they would often have to rewrite the program, or at least parts of it, in C or Fortran or something that runs really fast. And that was a big overhead. And that slowed down, in particular, researchers who didn't want or really need to be programming experts, but it forced them to do that. So what they wanted to do was come up with a simple Python-like syntax for people who weren't professional programmers. They wanted to design the language to automatically support current concurrency and just in general be as fast as possible. And it turns out that Julia is one of the 3 petaflop languages. These are the fastest languages that that we have so far created. So there's C, there's Fortran, and now there's Julia. And they also wanted to make it possible. They didn't want to have to rewrite everything from scratch. So they wanted to make it possible to seamlessly call C, Fortran, Python, I think Ruby. So if there's a module that's already been written in Python and that part doesn't need to be maximally fast, but your other parts need to. Julia also has matrix multiplication built in, a lot of very nice fancy things. So if you're a numerical programmer, it's really a nice thing to have. So they wanted to do all of this magical stuff, and they did it. So the way Julia works is the first time that you call a function, it's kind of a combination of a static and dynamic language. So the first time you call a function, it uses LLVM to compile that function down to native code. And LLVM is a very fast compiler, and it's compiling it to native code on your machine. So that's probably about as good as you can do. And they incorporated language constructs that made both async calls and parallelism basically integral to that language. We can look at a couple of examples. Here is the definition of a Fibonacci function defined in a single line. And so you can see this is even more succinct than what I was showing you in Kotlin. In this case, I don't even need to say that this is a function. It's saying this new name with this argument n is equal to this definition. So it's going to return the result on the right as when you call that function. It also has type inference. So it's figuring out from this that we're dealing with integers. And you can make the types explicit if you want, but most of the time it can infer the types. And you may be familiar with the question mark colon syntax for if else. So this is saying if n is less than 2, return n. Else, return Fibo of n minus 1 plus Fibo of n minus 2, the Fibonacci function that we're used to seeing. And when you call this, it will compile it and optimize it. Now, one thing I don't know about this is whether it has tail recursion built into it or if you have to do something explicit with tail recursion. But my guess is that it's going to recognize this and use a built-in tail recursion without you having to know what tail recursion is. Here is a different version of that function. So it's done iteratively, and we can see it has a function definition, so we say function here. And here's our Fibonacci, Fibo again. And this looks a bit like Ruby, because we have an end statement. And you can go back and forth if you've ever looked at Python, whether you think indentation is a good idea or not. I mean, you're always going to indent your code, otherwise it's more complicated. But they made a kind of an intermediate thing, which I can't fault too much, where they have an end statement, but they don't have Ruby's begin, because that was superfluous. So you can see we have an assignment, a multi-assignment here, and this is a tuple on the right-hand side. So x gets 0 and y gets 1. We have a for expression which iterates through using this 1 colon n, so you can kind of see what that means. And any sort of block statement needs an end statement, but it doesn't need a begin. So we're just doing a Fibonacci, we're returning x, and then this is the end of the function. And then down here we have a kind of a main, which iterates 1 to 10 and prints them. So you can see that it's fairly straightforward. The syntax of this is fairly straightforward, but what's interesting is how fast these things run. And they're still working on it. Julia 1.0 came out maybe a year and a half ago, and there's conferences, and there are, if you go to the website, you'll find things to learn about there. There's if you want to play with Julia in the browser, and there are introductory lectures on YouTube, and there's conference videos. So that's basically how I've been learning about it. I haven't applied it to anything yet, but I think this is one of the things that's going to change, because why would you go to the trouble of writing something in Python and then optimizing it or some other language when you have this and you're going to be able to work much faster? Ultimately, that's what it comes down to, is how quickly can you produce good results. One of the things that I think is important with Julia is how it's going to affect research. Say, a chemist who's working on, say, an energy problem or batteries or something like that, they're going to be able to work much more quickly and get results much more quickly. So this is a very important technology. The third thing that I want to talk about is the browser. And if you don't believe that JavaScript is holding us back, read this book. Even though the book's title is called JavaScript, The Good Parts, what you'll see in the book is all the problems that we have with JavaScript. And since this book has come out, JavaScript has definitely been improved, but it still has some essential features that cause a lot of problems and slow us down. And so what would be nice is to get away from JavaScript, but because the language itself is built into the browser, we haven't been able to do that until now. Here's one example of where JavaScript is very funky and difficult. If you're using double equal signs, these are all the different conversions that can take place, and it's very difficult to understand them all. Apparently, one of the solutions is to use triple equals, but that's the point at which I would say we have a language design problem. So the answer is called WebAssembly. I put philosophy in quotes because it's not really a language, but a technology. The idea is that we want to open the browser, one of the ideas is we want to open the browser to all languages, and currently, I think the two main browsers, since Microsoft is basically moving out of the browser scene and just using Chrome, the two main browsers already support WebAssembly. And there are compile languages like C, C++, Rust, and Go. There's implementations for things like Python and other languages. So it's already there. And one of the benefits is speed. I'd say that, in my opinion, the two greatest benefits are you can program in a more civilized language, and you get the speed effect. And the modules that you create for WebAssembly can be called from JavaScript. So you can create modules that are compiled and compact and fast. And then if somebody needs to use them from JavaScript, they can. But you can also build your whole user interface using your language of choice. And I would argue that most languages now have their, there's a Kotlin JS and there's a Scala JS and there's all these JSs so that you can program in the back end with your language, and you can also program in the front end with your language. And of course, Node.js goes in the other direction. So I would argue that that is the compelling reason for wanting, one compelling reason for wanting to do this. The modules are faster to load. You could also say that they're probably safer because it's going to be at least harder to decompile them and mess around with them than it is for JavaScript. So there are languages. There's a bunch of languages which you can find at this URL, AwesomeWasm, and and it lists all these languages that are currently available for using with WebAssembly. So that's something that you might want to look into and try out. On my way to the airport, I was listening to a podcast where the fellow who started this company, Wasmer.io, was looking at WebAssembly from another standpoint, which is to create universal binaries for all platforms, not just the browser. And the idea is that you will compile it once, and it'll run on all platforms without recompilation. So this will require something like the JVM, but it's much smaller and faster to start up. So instead of using, say, foreign function calls or Docker Kubernetes, which has its own startup time, you could use these WebAssembly universal binaries as a way to make putting programs together much faster. So this is a really fascinating thing, and if you want to know more about that, go to this wasmer.io site. And there's a couple of other interesting languages that I've looked at. One is Elm, and this is pure functional language, pure functional programming on the browser. Basically what it is Haskell on the browser. But it's not quite as, or at least I didn't find it as difficult to understand as Haskell. And there are some good tutorials out there. And this is very interesting because it prevents runtime errors. It finds everything at compile time. And it has a bunch of other nice features. So if you make a mistake, it has very good error messages. And it's worth looking into if you're thinking of doing something that is going to involve a lot of front-end programming. The other language is Pony, which is concurrent programming, but it uses the actor model. And this is a relatively simple thing to understand. And Pony, from what I've looked at it, I first learned about it at the Winter Tech Forum conference from Carl Quinn, who some of you may remember was one of the original Java Posse people, and that's how we started the Java Posse Roundup, which became the Winter Tech Forum eventually. And Carl is a big fan of this language and has played around with it a lot. And from what I've looked into it, it's quite fascinating. So that's another way to. I like languages. I find them fascinating. So if you do too, this would be one to look at. Just as a reminder, let's see, I'm getting close to being out of time. Just as a reminder, I'm going to try this experiment with open discussion. So watch the GeeCON Slack channel. And now I'm ready for questions. And I'm going to look at the, let's see. All right. Oops, that's not it. It's this. Okay. All right, so why is Kotlin better than Scala? In the town where I live, which is very small, surprisingly enough, we have a few pretty good programmers in the town, and two of my friends are Scala fans, and so we kind of struggle over this. But I would say that what Kotlin has over Scala, in my experience, is that Scala is designed as an experimental language, even though, yes, some amazing things have been created in Scala, and people have used it in production. But ultimately, there were a lot of experiments done with Scala, and not all those experiments have worked out, and it's left what I refer to as jagged edges in the language. And that's kind of what drove me away from it, is that and you know, if you're a good Scala programmer, you probably won't see these, or you know, it doesn't bother you very much. So it's the simplicity. It's going to be easier for the vast majority of people to learn it. And Scala was in that position, and I know that people tried to learn it and either ended up using a subset of the language so that they wouldn't get overwhelmed and the people reading their code wouldn't get overwhelmed, or deciding not to use it at all. So anyway, I would say simplicity and clarity. You can argue about that, but that's my opinion. Do you think that Kotlin or some other language will kill Java? Well, in the same way that C++ hasn't really killed C, there's so much Java code out there that I don't think that Java code's going to go away, and Kotlin is designed to easily use that code. So no, I don't think it'll kill it, but I think more and more people, I mean, if you look at the Android programmers right now, in a very short period of time, I think, don't quote me on this, but I believe I came across something that said that over 50% of the Android programmers are using Kotlin already. So that gives you an idea. I think for legacy code, Java will be around, but then, there are probably some things that people will start rewriting in Kotlin just because it's easier to maintain. Do extension functions violate OOP principles? No, because they can't reach in and modify anything that's private or protected. Will Kotlin one day go outside the JVM? It's already there. Kotlin has, it's called Kotlin native, so you can compile Kotlin down to native code for, I'm actually not sure which platforms. I know, Windows and the Mac and Linux, it'll do it, but it could also do it for, dedicated machine platforms and things like that. So yes, totally feasible. That's one of the impressive things about the language is what they've done with it. Do you think that Java will eventually catch up with new JVM languages? Again, my opinion, well, there are certain things. For one thing, they have done amazing things. Brian Getz, in particular, since he took over the Java project, he's done things that I didn't think were possible. You still have some of the baggage because they have to be reasonably backwards compatible with old Java code. I mean, that was one of their promises. So that will always be there, and I think they can only do so much. And I'm not sure where that limit will be, but I think they'll hit that limit, and at some point you'll say, well, Java does this, Kotlin does that. New programmers will probably go into Kotlin rather than Java. So I wouldn't say doomed. I would just say that it's always going to carry that baggage in the same way that C++ and C always carry some baggage with them. Doesn't the fun keyword suggest that programming in Kotlin is more fun than it really is? I don't know. I mean, I like it. Yes, I thought that was cute. I mean, remember, these are people who speak Russian as their native language. They're all super smart. I'm really impressed with them. But, and I've also been told that they're huge Rick and Morty fans. At least my co-author, Svetlana, is a big Rick and Morty fan, so you'll see some Rick and Morty references. Does anybody know what that is? Or? Yeah, okay, some people do. The rest of you, you're missing out. What do you think about Groovy as an alternative for Java instead of Kotlin? I think Groovy has its niche. I tried using it for, most of my experience with Groovy has been in creating the build files for, remind me, what's the build tool called? Gradle, thank you. So for Gradle, and the problem with that is that you don't necessarily know what those objects can do, whereas now Gradle is moving to use Kotlin, or it supports Kotlin as well as Groovy, and the development tools can then allow you, they can say, here are the things you can do with this particular Gradle object, and that's very helpful. Do I think that WebAssembly will end up the same as Java applets? No, for many reasons. Java applets were poorly designed, rushed out. They had all kinds of limitations. Whereas WebAssembly is actually an assembly language. It's running on a virtual machine, but it's an assembly language, so you can implement anything in it. You could probably implement Java applets in WebAssembly. So if you really love those, you could remake them. Can WebAssembly finally kill JavaScript? I don't know if anything can ever kill JavaScript, but it gives you alternatives. And it allows that kind of seamless back and forth between JavaScript and WebAssembly. If you have huge amounts of JavaScript, you can stick some WebAssembly modules in without having to abandon your JavaScript, and I think that's probably the best way forward. So no, but at least it'll make our lives easier. Won't Grail VM remove this? I don't know what that is, so I can't comment on that. Yes, it is possible to use Python libraries from Julia. That was part of the design spec of Julia, to easily use Python libraries. What do you like most about nonviolent communication? How does it help you? Can you share any stories? Let's see. I think this is the end of the day, so I can keep going unless somebody tells me to stop. And I have 15 minutes. Okay. If you reset the counter, I can, I'll go to 5:30. So nonviolent communication was actually a real revelation for me, because I had gone through my life avoiding conflict. I was afraid of it because, all kinds of reasons. I don't like to argue. I don't like to fight about things. And also, I was afraid to go into situations where I had to ask for things or assert myself, or just deal with difficult topics that might make people unhappy. And when I began to learn it, one of the experiences that I had was regret, because I realized how different my life could have been if I'd have learned this in, say, high school. And I would have been able to make different choices because I could see what the possibilities were instead of being afraid of them. And it helps me dramatically because of that, because I'm willing to take risks that I wasn't willing to take before. And my friends back in Crested Butte often will, even though I introduce the idea to them, they will often coach or suggest corrections to me because they've at times picked it up better than I have. So yes, here's a story. I was at a workshop for something different, and I made a dumb statement, and somebody else in the workshop, this made them angry because it pushed one of their buttons. And they called me out on it, and they were mad about it. And my normal experience in a situation like that is to simply say, well, that person I'm never going to have any interaction with. They don't exist now. And that was my safe way of dealing with the fear of conflict. And this person happened to end up at the lunch table with me, and I started talking about nonviolent communication and being afraid to talk to this person because we had had this tiff. And they said, well, can you give me an example of how that worked? And I took the plunge and I said, well, for example, that discussion that we had in the workshop, if I was doing it using nonviolent communication, I would have done it this way. And we began talking about it, and by the end of the workshop, we were terrific friends. And that normally wouldn't have happened. I wouldn't have had that experience. So that's just one example. And I'm not perfect at it. Nobody is. You can always get a button push that throws you off the horse. But this is a way to get back on instead of my previous way of dealing with things, which is if I fell off the horse, I would simply run away from the whole experience. And now I know how to get back on. Let's see. Will WebAssembly open new front-end library mess like AWT Java, Swing and Java? It could, because anybody can develop front-end libraries. WebAssembly is not Well, I would say it's, because nobody really programs directly in assembly language anymore. They use a high-level language. So you could use one of your high-level languages to create bad libraries. There's nothing to prevent you from doing that. But most likely, you're going to have, say, Kotlin library in WebAssembly, and it'll make sense to a Kotlin programmer. So there won't be, I would say, no, there's not going to be a universal library. But what is really, I think, important is that they're working on library management tools. And so that part of that mess that we see with JavaScript shouldn't happen. We shouldn't end up with inherit or, download the world for an app. That we should be able to prevent that. How is it possible that Julia is both high speed and high level? Brilliant design, but probably the easiest way to look at it is a combination of being able to automatically compile everything to native code using LLVM and a design that optimizes for concurrency. So I would say those two things allow that to happen. What are some of the drawbacks that WebAssembly may have for languages that are object-oriented in nature? Does it make sense to compile Java to WebAssembly? Yes, you could compile Java to WebAssembly. I don't see, again, it's just like C++ compiles to native code. Java compiles to the JVM, which is basically bytecodes are like an assembly language. So there's nothing that would restrict you. They've got PHP compiling to WebAssembly, and that abomination of a language, if you can make that work on WebAssembly, then no, there aren't limitations. What about Swift? If you're asking, will Swift work on WebAssembly, I'm sure it will if it doesn't already. If you're saying, is it a good language? What I've read, I did look over Swift when I first saw it. Actually, I think after the first version wasn't very impressive, but after they've done a couple of versions, it looks very nice. The problem that I have with it is that it tends to be specific to iOS, and I have gotten burned too many times by going into languages that are just used in one domain. So effectively, it's an Apple language, and I don't want to be tied down by a language that does that. However, there's like Flutter compiles to both Swift and to Kotlin. So there's an example of where you can move up a level and create something for the front end that you don't have to worry about the specifics of what language what platform it's working on. However, they're working on a compiled version of Kotlin, native Kotlin, that will run on iOS as well as on Android and other things, but in particular to deal with the multi-platform handheld issue. What is the most annoying thing about Java, in your opinion? Wow. Where to start? I guess, I've always been frustrated by what has seemed to me to be the sloppiness in the design. But if you were to pick a particular feature, I would say the threading system was just, the fact that they had to later remove features suggests that it was very sloppily put together. The verbosity of it, the unnecessary verbosity of it, the fact that they didn't look forward a little bit and allow us to have type inference. Even the type inference that we have still isn't as good as type inference in languages that were designed that way. I mean, basically, thinking in Java answers all of those questions, because what I was trying to do with that book is to, I mean, other than teach the language, actually show you all the flaws so that when you encountered them and you scratched your head, why is it this way? You could understand that, you know, why that design, well, that it is a design flaw. It's not you. It's the designers of the language that made that mistake. And so you don't have to feel silly or stupid because it doesn't make sense to you. It actually doesn't make sense. Will Java become too big a mess to learn like C++? Eventually, I don't know. I mean, I was very frustrated by the fact that I had to write a couple of chapters before I could honestly give you the Hello World example, because I didn't want people to not understand every single line and keyword in Hello World. That's another point of frustration. So I guess it's the libraries really that make it difficult to learn. I don't know. That's probably all I can say about that. How does Go performance compare to Julia? I don't know. I've only been studying Julia. I suspect, well, Go is not a petaflop language and Julia is, so Julia is faster. So I could answer that one. If we can extend a class with a function, can we borrow it from another class? I assume you're talking about Kotlin here. Okay, yeah, extension functions. Can we borrow it from another class? If we can extend a class with a function, can we borrow that function from another class? Is that what you meant? Yeah, I'm not really sure what that question is. So since no one's piping up and telling me what they mean, I will go to the last question, which is Kotlin native faster than the JVM? Generally, yes, it would be, because it's being compiled to native code. So yes, and that's one of the arguments for it, because if it wasn't faster than the JVM, in many cases you'd just be able to use the JVM. But so part of it is you want to be able to target different platforms like iOS, but the other part is for speed. All right, that's the last question. I will let the rest of you go, and if you are around tomorrow, I will try and be around tomorrow, so if you have books that you want signed, or if you want to get pictures taken, or you want to have discussions, watch the Slack channel, and I'll try and post whenever we know where our space is, whether it's just out in the lobby or if it's one of these rooms. Thank you.